The sheer volume of data available to businesses today is overwhelming. However, most companies struggle to translate this data into practical, applicable insights. Information from various sources such as spreadsheets, reports, and customer feedback remains underutilized and fails to inform effective decision making. The core challenge, therefore, is not merely acquiring data, it's managing its complexity effectively to support informed decision making. I'm Monica Polemitis, and my work focuses on helping businesses build data strategies that achieve precisely this outcome. And today, we look beyond the technical jargon to discuss data architecture. This term essentially refers to the underlying system your business uses to store, manage, and ultimately access its data assets. Implementing an appropriate architecture significantly supports your operations and goals. Conversely, an unsuitable or outdated architecture can easily become a bottleneck, hindering progress and potentially leading to missed opportunities in a very competitive landscape. So in this video, I'll briefly explore the main architectural approaches seen today: the long-established data warehouse, the more adaptable data lake, and the increasingly prevalent hybrid model known as the data lakehouse. My aim is that by the end of this video, you'll have a clear understanding of how these approaches differ and which might best align with your specific business needs, enabling more informed strategic choices about your data architecture. All right, before picking a data system, the first step is knowing your ingredients, the actual types of data you have. Why? Because different data types need different kinds of handling and storage. So first up, we have structured data. And think of this as data that plays by the rules. It fits perfectly into organized tables like rows and columns in a spreadsheet or a database. Your sales figures, customer addresses, inventory counts, that's typically structured data. It's predictable and works easily with most standard reporting tools. And then we have semi-structured data. This data has some level of internal organization, maybe using tags or markers, but it doesn't fit neatly into those strict tables. Let me give you some examples. Website logs tracking user clicks and data feeds from certain apps, that is semi-structured data. It offers more flexibility than structured data, but requires a bit more effort to make sense of. And the third category, which is increasingly vital, is unstructured data. This is essentially everything else: the text of emails, transcripts from customer calls, social media comments, videos, images, PDF documents. It doesn't follow a predefined format, making it the most challenging to analyze with traditional methods. However, this is often where hidden gems of insight about your customers and business lie buried. So understanding this mix, how much structured, semi-structured, and unstructured data you need to manage and analyze, is absolutely key because each type places different demands on the data architecture you choose. Now let's look at the systems. For many years, the data warehouse has served as a standard, reliable solution, particularly for business intelligence functions. You can think of it as a meticulously organized library specifically designed to handle clean, structured information effectively. It operates by taking data from various operational sources, then cleaning, transforming, and structuring it, typically through a process known as ETL, which stands for extract, transform, load, before storing it in a highly organized manner optimized for reporting and dashboard creation. The primary strength of the data warehouse lie in its consistency, its strong support for data governance, and its proven effectiveness in supporting standard business intelligence reporting needs. However, a key limitation is its inherent rigidity. This structure means it struggles to effectively handle diverse, messy, semi-structured, or unstructured data formats. Also, if your business requires the flexibility to explore data freely or to ask entirely new kinds of questions not anticipated and during the initial design phase, its predefined structure can prove inflexible and slow to adapt to evolving analytical requirements. These limitations, especially concerning data variety and the need for greater analytical flexibility, contributed significantly to the emergence of the data lake concept. Imagine this as a large, versatile reservoir capable of holding vast amounts of information in its original, unaltered state. A data lake architecture allows you to store all types of data, structured, semi-structured, and unstructured, side by side in their raw format without the prerequisite of defining their structure upfront. The process often used here is referred to as ELT, which stands for Extract, Load, Transform, where data is first extracted from sources and loaded into the lake, transformation and structuring occurring later on demand when needed for specific analytical tasks. This approach offers considerable flexibility, making it well suited for handling highly diverse datasets, enabling data exploration and experimentation, and powering advanced analytics or machine learning models that often benefit from access to raw, detailed information. However, this inherent flexibility introduces a potential risk that requires careful management. Without robust governance practices consistently applied, including comprehensive metadata management, data quality checks, and clearly defined access controls, there is a significant risk of the data lake degrading into what's commonly termed as a data swamp. In such state, data becomes difficult to navigate, its trustworthiness diminishes, and the efficient extraction of meaningful insights becomes increasingly challenging. The desire to harness the storage flexibility of the data lake while retaining the reliability, performance, and governance features typically associated with a data warehouse led directly to the development of the Lakehouse. This modern hybrid architecture aims to provide the advantages of both the data warehouse and the data lake, often integrating them within a single unified platform. It achieves this by allowing the storage of all data types, much like a data lake, while simultaneously incorporating robust mechanisms for defining structure, managing data quality, optimizing query performance, and enforcing governance rules, similar to a data warehouse. The key benefit offered by the Lakehouse is a potentially unified and more efficient data ecosystem. It can accommodate vast amounts of varied data while enabling the application of necessary controls and quality assurances. This design potentially allows diverse teams, from traditional business intelligence analysts needing structured reports to data scientists requiring access to raw data for complex modeling, to work in a single, consistent, and governed source of truth. Consequently, this approach can help reduce data redundancy, streamline data workflows, improve operational efficiency, and maintain a higher level of data trustworthiness across the business. The ability of the Lakehouse to balance the often competing demands for speed, flexibility, and reliable governance explains why this architecture is currently gaining considerable attention and adoption. Having outlined these three architectural approaches, let's consider how you might determine the most suitable path, warehouse, lake, or lakehouse, for your own business. It's crucial to understand that there isn't a single correct answer. The optimal choice is highly dependent on your unique business context and objectives. The decision depends on carefully evaluating several factors specific to you. Primarily, you need to consider the types of data that are most prevalent and strategically important within your operations. Alongside this, think about who needs access to this data and for what specific purposes. Are they primarily running standardized reports, or are they conducting exploratory analysis and building predictive models? Also, assess the required speed and agility for analysis and adaptation. Are current reporting cycles sufficient, or does your business demand faster responses to new questions and rapidly changing market conditions? Let me give you an example. If your business's core activities rely heavily on standardized reporting derived mainly from well-structured data sources, and the need for ad hoc exploration is limited, then a traditional well-managed data warehouse might still provide adequate functionality. However, if your business faces significant volumes and a wide variety of data, including unstructured formats, and possesses a strategic need for greater flexibility to support exploratory analysis, data science initiatives, or advanced AI development, you will likely find the constraints of a traditional data warehouse too restrictive. In these scenarios, a data lake offers the necessary capacity to ingest and store diverse raw data. It's important to remember, though, that realizing the value of a data lake critically depends on implementing and maintaining strong governance practices to prevent it from becoming difficult to use effectively avoiding that data swamp scenario. The Lakehouse architecture then emerges as a particularly compelling option when a business requires both the robust governance and reporting capabilities of a warehouse and the flexibility to manage and analyze all data types, including raw data for data science, within a single coherent system. It aims to bridge this gap, often representing a strategic choice for organizations needing versatile, reliable, and scalable data management. In closing, the most important point I want to leave you with is this: selecting your organization's data architecture transcends being a purely technical IT decision confined to the back office. It is fundamentally a strategic business leadership decision. The architecture you choose directly influences how readily your organization can innovate, how deeply you can understand your customers and market dynamics, and ultimately how effectively you can compete and adapt in today's volatile environment. Because sustainable competitive advantage doesn't usually stem from simply processing large volumes of data. Rather, it arises from empowering your people to access, interpret, and utilize that data meaningfully and effectively. Thank you for your time.